Just give me one last chat. Yes, of course. Now it works. Yes. So you can hear me, and I can share as far as I see. Yep.
Yeah. Currently, it's all very good. By the way, I just want to tell people Dmitry was also in JPrime in Bulgaria, right?
Yes.
It was very awesome event. We were trying to prepare for this conference, so I couldn't catch all the things. But when I checked your YouTube stream, it was really people were enjoying, I guess, very much.
Oh, that was awesome. Yes, exactly. So it was one of the reasons why I cannot come to Istanbul personally, because unfortunately, we just made this conference. It was more than 1,000 people, which was unexpected for us. People were just, so much aiming for in-person events. So absolutely, just too short distance between our two conferences, but there will be speakers from our conference. We're traveling now to Istanbul, so we are passing them to you, and then we will enjoy good sessions. Once again, it was an amazing event, so feel free to come next year to us as well. You're very welcome. And yes, it was this forgotten experience by in-person conferences. So I even envy for tomorrow that I can be there, but it's a great pleasure for me and honor to be here with you today.
Yeah, thank you so much. And the stage is yours. I will maybe not be around for 15 minutes, but Nursel is online, and Özlem will help if there is any technical issues. I hope there will not be. So go on.
Thank you. How's it? Teşekkür ederiz. Thank you so much. And yes, once again, great honor and pleasure for me to be here. This should be like a green screen with some picture on it, but I couldn't make it on this tool. Sorry for that. But we were able to share the screen. And once again, I'm so sorry I'm not able to come tomorrow and do it offline. But next time I definitely will come. I really want to join your community. I know that it's great there, and I envy the speakers who are just now coming to Istanbul to your conference. So today I'm going to talk to you about the tool I'm working on, not a framework actually I'm working on, and this is a great honor because well, to tell the stuff you're working on is really, really awesome. Before that, of course, I work for Oracle, so that's why whenever you take your annual business decisions, just check it once again if everything is okay. And yes, my name is Dmitry. I write code for Oracle. Not an advocate, just doing a little bit of that. So that's why the things I'm going to show, I'm also part of it, and I'm actually coding them. So let's actually see, and the agenda for today will be what is actually Helidon. Just for those who don't know, it will be very short, but then we will check to the Reactive Engine and what is Reactive and why Helidon Reactive actually is cool. And we will actually see what is good blocking or non-blocking way of doing stuff. So we will do some kind of a measurement between them. And you will see this raw life, which is actually good. So once again, I'll try to be very short here because there are different talks about what Helidon is, but so you can easily find them about Helidon introductory. Just type it in YouTube, and you will see talk from me or from my colleague about that. But for those of you who don't know, so that's a set of Java or even Kotlin libraries for developing microservices. So whenever you need to make a microservice in Java, Helidon is definitely the choice because once again, it has a wonderful name, which is actually means swallow. It is open sourced under Apache 2.0 license. Once again, this is not typical for Oracle, but we are one of the first projects actually who are open sourced under Apache 2.0 license. We are very fast because we're built on top of Netty and we are cloud native ready. So that means that we are not only like serving your REST requests, but we're also having all the infrastructure for you to run in the clouds, like health metric tracing, etc. And we have, I probably think, one of the best Groundbreaker native image supports. Just because you pay a lot of attention there. And if you see the number, so usually a microservice can be really, really small with really cool startup times. And once again, if you see here, so we have 3 options for packaging it, which makes us quite unique here is because, once again, we are living in so-called Java post-11 world, or just for the upcoming Helidon version 3, the baseline will be Java 17. So for Helidon 2.x, it's 11, or to 3, it will be 17. That means that we enjoy all the benefits from this world, and that means that we package not only like jar, with hollow jar with libraries. We package not only native image builds, but we also package custom builds. How to say J-Link custom images. So that means that you only build the modules that you actually had, and you just throw away all the code you don't need. And that makes the sizes even smaller, the startups better, and you simply don't have any dead code. Will be a security issue. So we are really good at that. And once again, for all people who don't know, Helidon has actually two main flavors, I would say, which makes it quite unique. So first one, the most, I would say advanced, not advanced, but popular, and I would say it will suit for most of your needs, is the Helidon micro profile, or Helidon MP, which is like in top, and it is built actually on micro profile, following the micro profile specification. I'll tell about it later. Then underneath, there's this Helidon reactive layer, which is actually wrapping netty, as you see that's down there, and it provides you a lot of functionality, and it is fully reactive, and we'll actually explore it right after actually give you a small comparison. So as I said, we have two flavors. One is Helidon SE, which is following totally functional Java only way of writing code. So I would say no magic, pure Java, pure reactive Java. There's only one annotation used, which is override. And on the other side is Helidon MP, which is like a declarative style. It's a Java EE style, Jakarta EE style of reading things. So you get a bunch of annotations, which are by profile, and there's a lot of magic happening there. So they will actually not secure, but prepare everything for you. These annotations, you will write POJOs, but with this annotation, you actually make a lot of magic there, and it turns your POJOs to some real cool REST endpoints or gRPC endpoints or GraphQL endpoints. And just a few annotations, your POJOs turn to be really like cool. But it comes with a price, of performance. So as I say, if Helidon MP is fast, then Helidon SE is really fast. But still, Helidon MP, as I say, it's best in micro profile. So micro profile as a set of specifications. So back in 2016, I guess, several big vendors sat together and say, okay, we need to make a common specification to make actually our core code portable inside of that specifications. And the main idea is that you don't need to actually write vendor-specific code to make your application run. So you can easily port between different vendors. So that means that if you write microprofile code with standard code for you, you can easily migrate to Helidon without actually rewriting anything. And these are like 13 specifications. We're specially designed for microservices world, so you have everything for that. As microservices are usually like a good example of what I call a distributed system, so they can fail easily. So we have everything for them, like fault tolerance to keep information about how you. It's not information, but how to behave whenever something has failed. You can monitor and observe them with metric health checks to trace how many actually requests through which microservices go. And of course, you can all manage this through CDI and to secure it via join. So once again, this is just a set of specification. Helidon is just one of the implementations there. And once again, you can easily port, if you have something written in microprofile, you can easily port to migrate to Helidon, and it will cost you less, like almost nothing there. And if you migrate, you can actually receive even more, not only microprofile, but you also will have some services like Jakarta persistence. You will also have it out of the box, like WebSocket, you will have it out of the box. Sorry for that. RESTful web services, once again, transactions, annotations, and even more than that. So you have other specifications which are also under micro profile, but they're not main part of it, which is like GraphQL and LRA. So we also do support them. And of course, it's very much required nowadays. You will also have it, and gRPC, because like it's very famous and popular. People use it a lot. You will also have it out of the box. And what makes, once again, Helidon MP quite unique is that we have for CDI a full well support. That means we completely follow the standard. That means that whenever you have any CDI extension, so our extension mechanism actually is based on CDI. So whenever you want to extend something with Helidon, you just use regular CDI extensions. They can be even from other vendors. Like, we used some CDI extensions from, I guess, Open Liberty, and it simply worked because it's CDI. And they all work also in GraalVM, so you can make GraalVM native image just out of them. And this is actually a small introduction to Helidon MP, but this will not be our focus today. Why? Well, actually, because it is blocking. So, well, we write like simple code and we block the thread, and it's very easy to write, but we need performance. And whenever we need performance, we actually have decided that this intermediate layer, we actually ROPSNetty, is a self-sufficient product, which is very, very cool. And I'm going to tell about it exactly today. And I will show you like demos for that. So once again, it's technically the same. And because it is the same, but all in reactive, so you follow technically the same specifications, you have still full control of them, and you have still the full performance that you have, because it's a Java only code with absolutely no magic. That's why we sometimes call it like danger zone. So you really gain the full performance that you actually want to have using this intermediate Helidon SE or Helidon Reactive APIs. And here, well, once again, it's a still framework. It is still shipped. The product using it will be shipped in 3 ways. So it will be just a jar or a custom image based with JLink instruments, or it will be a native image. But here you see the numbers are really, really small. Once again, just because we throw away all the things which are like following the standards, and we are completely reactive there. So, and you will ask me, okay, what is reactive? So it recently become a buzzword, but let's take a look at some retrospective. So as you see, the quantity of data, like, gets more and more each year. So we are thinking in hundreds of zettabytes, and these things have to be processed somehow. And once again, just adding a lot of threads. And with the CPUs that we have right now, so we have like somehow hit the floor with the Moore law. So we cannot get more and more gigahertz. We cannot get more and more, transistors. We can, but we cannot like just linearly grow in our processing power. So most of the processors are now like multi-threaded, and as I said, it's running on the thread, and blocking the thread isn't the best use for that. So that's why we are started thinking about how to process things asynchronously, just to save the time. So you have something, you put it on a thread, and you don't have this other thread to work. And whenever the result is done, you just call in an asynchronous way the result. So that was my talk. You can just take a look at it. Exactly what in Java 8, one of the best functionalities come was actually completable futures. And here is a talk about it. And actually making asynchronous in a good way with completable futures really like solved us a lot of stuff. But things continue to evolve. And by the way, with completable future, we actually solve the problem of asynchronous call with all this callback hell that we really love. So they do solve it, and they do solve it in a good way. But actually, we continue to evolve, and the main idea of the main paradigm was shifted just because we were following this idea of asynchronous programming and asynchronous um, doing way of stuff, just to completely utilize the resources that we have. So as you see from this copy paste from Wikipedia, I'm quite respect. So we shifted the paradigm that now everything is like a data stream, and everything is a propagation of change. So this way you start, expressing static stuff like arrays or event emitters. So like they communicate via this propagation of flow of data flow and propagation of change happening there. And of course, there's a reactive manifesto for that, because every good thing has a manifesto. It's still there, by the way, so you can check it on reactivemanifesto.org. But the main idea of what our reactive programs are, that they are responsive, they are resilient, so that means that it can gracefully handle the exception that may happen. So they're message driven, so everything is a propagation of change. Messages coming and you react on them. And reactive applications are usually designed to grow very much easily in horizontal way, or just elastic as it's said here. And whenever we think of reactive, so we think about unblocking plus this thing: responsive, resilient, message-driven, elastic. There's a good talk about by Venkat Subramaniam. So my personal guru, I thank him so much for sharing all this thing with us in the community. So you have like 3 channels that you control the thing. So you get data flow as a data flow. There is the complete channel, like whenever data flow is gone, whenever data flow has to be like controlled in a complete channel. And whenever there is a error or something has happened, so there is another way to control the situation. So it simply does not block anything, but we know that there is an error, and one can easily react on that error in a graceful way. So I will definitely show this in an example. So once again, one flow that data is coming and start blocking. Complete channel, when everything is ready, we just notify. And we have channel for good reactions on errors. Just once again, more details here. It's a big talk about it by Venkat. Just type in reactive programming with Venkat, and you will see a really great explanation about that. But since we're limited in time and I want to show you and compare it, I will continue. As a result, as an evolution, we have something called reactive streams. Like, we have data flows. And because as I saw the data, all the streaming, Netflix's movies, like, great amount of devices would actually stream a lot of events. So this concept of reactive stream is born to provide an asynchronous stream processing with non-blocking back pressure. So back pressure actually comes as an integral part of this model. That means that now it's not just a flow of things which just happen. The other side can also say, guys, I cannot consume so much, so please, stop it for now, or I'm ready to do this. But the main idea is that this is like, you can consider this as 2 systems talking across asynchronous boundary. So this boundaries can actually be like even your threads, like just passing data from thread to thread, can also be like a time-consuming and resource-consuming operation. And once again, they still talk to each other. That means that you have a back pressure, and it is fully non-blocking as asynchronous. This way, we utilize the resources at their maximum. And thus, in Java 9, for this stuff, another API was actually born, because from Java 9.8 we mostly use like streaming API, which is cool, but streaming API is like one channel only, which is data and processing. There's no other 3 channel, which is a control channel, or I would say complete channel and error channel. It's just the flow events. And to make it possible, this combination of iterator and observer pattern was meshed together to provide so-called flow API, since Java 9, it was provided mostly like an interface, which should have different implementations. So there is a subscriber which subscribes to publisher for callbacks. Once again, big influence on that had the Netty, just because they're streaming a lot of, not Netty, but Netflix, just because they're streaming a lot of movies, streaming a lot of data, movies, a lot of data. And whenever you have that, we subscribe to something, pushes the data in a synchronous way, and then the publisher, as you see, publish some stream of data to the items that are subscribed or registered subscriber. There is a subscription which actually puts them like together, and the processor which sits between publisher and subscriber. Whenever the change, the data needs to be somehow altered or done or changed, there's a processor in the middle. Once again, this is only an API, and there are implementation for that. And technically, you know that there are like several of them. And the most common you probably know are the RX Java, the Echo Streams, the Project Reactor, which is awesome. There is Unity, and there is even Apple Service Talk for that. But once again, for me personally, the best is Helidon, and I will tell you why. So Helidon Reactive Engine, let's actually have a look at that. So Helidon, like other projects, has its own set of reactive operations, and there is absolutely no dependencies from outside. So it's a complete ecosystem. What makes it good, Helidon, that you actually don't have any other external dependencies. So you just use like our module, which is like reactive, and you don't have anything from outside because our engine is our like own implementation. It still uses, it follows the IDE and follows the can work directly with the Flow API I told you earlier. It's based on reactive streams, and there you actually have two main chains can be made with two main operators, I would say. If you have multiple values that has to be processed, you have a multi-operator like this one. Like for example, you have a stream of something, and you just do some processing over that. Yes, that's going to be like a little bit misconcepted with streams, Java streams, normal streams. But here, once again, you have more control channel. So you have error channel, you have complete channel, and as a result, so you just do something with if I have stream of numbers, you just limit them, map them, and then process it, and it all comes asynchronously, and it all comes like in a non-blocking way. So whenever something is ready, we're done. Other than that, we're lazy. We give the processors to other consumers. The same is with single. A single, there's only one value, and this value also can be asynchronously processed, and whenever it's done, it can be like printed. And once again, it is fire and forget, which is good. And as a result, you have a bunch of reactive operators, so you can do everything. But the main is, of course, flat map. You can collect them, you can process it, you can map, you can reduce, you can find for, you can filter, you can peek, you can limit. Everything is there, and Helidon reactive operators are really cool, and they're available to you out of the box. You don't need anything from the side. You just use them. So, for example, if you say like if you want to process something in the middle. We publish, we do a multi with several elements. We just process them, and then we at the end we like compose them, subscribe to them, and show them to you. So you can just not only publish data and subscribe to it, but as you see, we're following this Flow API. We also can process data in the middle. And I also really cool that this API. Sorry, there's an artifact. I didn't see it. So this engine is really cool and really fast. So we are like sometimes comparing to other frameworks, and we can say that quite often we are faster. So that's why I consider it once again if you need even more performance. Now, as you have this engine, it's done. You have everything to make your things work in a reactive way. you can have a reactive web server. That means that this microservices you serve will be also served in a reactive way. And it's really cool, and it's small. So you just create something called web server. As you see, just created a main method. You do some routing over there. I will show you an example. And you just start it. And this start happens immediately. As the server is ready to serve requests, he will just notify us if he actually subscribes to that. And let us actually see it, because like seeing it in action is the best option. So yes, we have some folder I've prepared. To create a project in Helidon, we use our Helidon CLI. And it's just a binary available for all platforms. By the way, it's written in Java and just compiled into native image, and you can get it as a binary, but it's still written in Java, which is cool. Yes, you just do it and create it like init. So this way we initialize our project. As I said, we can do the microprofile project or Helidon SE. So for microprofile, you just choose option 2. For Helidon SE, choose option 1. And we will create our famous quick start application, which is a greeting application, which publishes one endpoint. We have a developer loop with that, so Helidon can actually care for all the changes which are happening during the code and actually reload everything for you. But once again, we don't have much time for that. But bear in mind, whenever you want to use work with Helidon, there's a CLI for you, and it's specially designed to make everything really easy. And we have generated the project, so we'll do quick start SE. And you see, it's very fast loaded. What we will have here, so to create a microservice which do greetings for us, it's extremely easy. So there's a main method. Again, it's just an application. With this main method, we'll load some configuration. Again, here's exactly this web server I was talking about. And we just configure it. So we have some resources, like what will be our greeting. It can be in YAML format, what will be the port. We can consume it from here, but as you see, we just add the configuration. We add support for JSONP because you can just throw it away if you don't need it. We want to talk to JSONP here. And as you see, here's exactly what I was talking about. The server itself is reactive. That means that it returns as not a server just when it starts, but just immediately starts and returns as like single, like one element with the server. And whenever that server is ready, we say in an asynchronous way, okay, the server is up and running, we just print it down. And whenever something goes wrong, this is the other channel, as I told you, the channel with error. Well, something can happen. The port is busy or whatever it is, and we fail gracefully. So there's this error that startup failed due to something happened. And you would wonder, okay, so just the server, how can we create a greeting, for example, like greeting a service or like a REST endpoint with those greetings. And we just create this greeting server under this endpoint. And this greeting service was, as I told you, we have only one actually annotation used, unlike others. It's override, and you just have to implement this service, which has only one actually function to override, which is update. And update means that you set to each endpoint its control. It's the function which actually processes it. And as I told you, we just have request and response as a parameters. And this is basically, for example, if you want to create something, we get a request. We create a JSON object. Here it's manually, but you can do this automatically. We have all the mappers for that available to you. This is just for demo purposes. And we just send it. And we do it in asynchronous way. So if you run it, by the way, what I like about it, if you run it, you can run it directly from the IDE just because it's a very small thing, and it runs, you see, in seconds, in fractions of seconds, it runs. Of course, you can package as a jar, but if we do some curls, which is like, oh, that was from the demo from jPrime, but this time I will say Istanbul. You know, just say hello Istanbul, or even Istanbul joke. this way you create an endpoint. It's very, very easy. It simply like works out of the box. But out of the box, you also have metrics. They give you all the metrics according to microprofile specifications, which is based on Prometheus mainly, or it can give you JSON output as well. Once again, this is cool about it because it's like it's there and it's working. And you can get health checks. Okay, health. It's a JSON. We're telling that I have a good machine, a lot of free memory, and that's it. And it's reactive. And you see how easy it is. You just create it, generate it, and it simply works, even directly in the IDE. Let's go back to slides now to show you a little more things here. Of course, as I told you, we have reactive messaging, and we're following the microprofile reactive messaging, but once again, in a synchronous reactive way, what makes this also quite unique. Just a few words about microprofile reactive messaging. So, as you see, send receive messages with back pressure and acknowledgement mechanism designed to create like reactive pipelines to make like message exchange really standard and following the reactive strategy, or actually reactive paradigm here. So just an annotation. Whenever you write Helidon MP, you will just use these annotations. Just an annotation like something, get something from this data when it's coming. And for example, you publish something to a channel, to publish some event. You just say what channel to put it, and it just delivers you. And it can be both reactive streams. It can be even ArcJava. It can be a reactor. If you probably know this, flux and monos. You just say flux, just do publish me something, and it will do just with one single annotations. In the middle, you can just produce it also from the imperative code, and the same way you actually consume it, as it was done in the slide. While like it's coming from that channel, just print it out whenever it's coming. Extremely easy. So more information about that you will read in the official documentation. But once again, the idea is to make a standard way for reactive messaging, and we can do all this thing. Well, reactive from terms of the reactive framework we're using. So it just actually does the same stuff as you have, but without any of those annotations, I would say. And once again, we have a concept of channel, which is like a publisher and subscriber. And in the middle, you have processor. So you can easily create like a messaging builder, as you say, a channel. This channel can have different implementation underneath. I will tell them about it later. But as you said, we just create a publisher which has a multi of several elements. You just put them in the channel, and there's a listener at the end. And whenever something comes intercepted, it will be done in an asynchronous reactive way, like it's written here. You can put a processor in the middle if you need to process the data. Once again, the idea is the same as microprofile messaging, but there you have a bunch of annotations that we don't use. And here we have our own reactive engine, and this reactive engine has no magic philosophy, just publish your event. We have, as you say, this construction, so it's multi and single. Publish them, they go directly to messaging, and you are following them. And as I say, the messages can go through different, communication channels. And these communication channels are actually different message broker system, I would say, like this. So it can be Kafka, because we all love Kafka. You just can pass these messages through Kafka and publish them and consume them, or process them in the middle. It can be JMS, it can be active queue, and soon we will have also our socket, a protocol specially designed for reactive, operations. We also oh yes, I get one question, but I will be right there. It is designed specially for reactive operations, but it's a special protocol for that. So just we also do have supported. I have a question. How does it manage bean and dependency injection? So in Helidon SE, you don't have dependency injections. This is the idea. It's pure Java. You have Helidon MP, which manages dependency injection with CDI. This is the standard way to do it. In Helidon SE, you don't have it. So this makes it so fast. When I show you the code, I just make a service and just call it. I'm just not making it somewhere and then the dependency injection will find it with annotations. No, it will just do it for us. Actually, I wanted to show you a small demo. I think we still have some time for that. If we, just a second. Now, let me open another project. So you can easily publish your events with, by the way, we started a little bit later. So if the organizers don't mind, I will also like use another several minutes. Thank you so much. Thank you. So if we open our own Helidon as Helidon code itself and go to the examples, we have an example with Kafka, message broker, who actually sent some messages to Kafka. As I said, we create a channel. Once again, for the dependency injection, we don't have dependency injection in SE. So that's why we just configure the service, and whenever we need a service, like for example sending messages, this is the sending server. You just create it, like implementing the service, and then you just configure it as you say. So we read the configuration. It's our own configuration engine. We create this Kafka channel where we push the events, like emit them. And then with Kafka, it's just sorry, I think I changed something. Yes. And then there is another endpoint which just consumes it. So it creates also incoming channels. So we get channel from Kafka. We take the name here. And with WebSocket, we push them. As you see, there's no dependency injection, no magic here. And this makes us quite unique, I would say. So let us just run a Kafka server. Oh yes, because I need a Docker. Just a second. My Docker updated yesterday, and I'm quite happy about it. Docker Zimmer is there. Please come as soon as possible. Let us try it again. This Docker. Okay, you see it's running. And now, whenever we run this server, not server, but this WebSocket example, the Java -jar, target, and WebSocket, I will precompile it for you. Starts so much fast. And actually, let me pull this application to you. It is here. So this is just a regular example. We send a message here. It goes as a message through Kafka, and then as a WebSocket, it's pushed back to us. So whenever we send something with the messaging, should it be Kafka? Should it be AQ adapter? Should it be JMS? It simply runs and it just pushes you very fast. So we get everything, and this happens reactively. What is good about this thing is that it's available in our official examples. I have not invented something special for you for this demo. Just run there, run the example, and you will have them. I will just have to stop it right now. Where is the run? Yes, and the Kafka itself. Oh, it's no problem for it to run for a while. So quite easy. Let's go back to slides. Of course, once reactive, everything has to be reactive, and here Helidon provides you a very good way of communicating. We have our own DB client, which actually wraps blocking drivers and provide you a reactive API to work with databases. Even once again, the database is reactive, you can still is blocking. You can still talk to it in a reactive way. It will put it in a separate executor. It will block there, and it won't block your machine as well. So we have this as a reactive GUI, as I say. We also have a reactive web client. That means whenever you consume resources from other web services, you shouldn't wait for them to happen. So you just do it also in a reactive way. That means that it's unblocking. You called it whenever it's ready. It's there. But I think I'll be quite quick here. But whenever, once again, reactive is hard, something very new is coming. So I'll a little bit show you the future. And this feature is called Bloom. It actually was a research project for so-called virtual threads, but it's also first was research, but now it actually comes to our JVMs, to our regular JVMs. And there's a JEP for that is 4.25, which is quite month old, I would say. And it actually introduces virtual thread to Java. You can play with the project and you can have this early access built. But what is the main idea? You have the threads as they become virtual, they can be become like millions of them. Thread is no longer a big resource. You have a new API for that. And once again, out of the box, wait a second. That's what I want to show you. As the main idea is that you have millions of them, and they run over the real threads. But the virtual machine takes care of managing how the real work is done. So that means that you write the blocking code. Like you don't need to make it like with this asynchronous operators, reactive operators. I mean, to do this all of the chain of the reactions. You just write the code as you used to write the code. And then virtual thread actually, for you, it's like normal, but the virtual machine manages how to put them on real so-called carrier threads. So this carrier threads are the real threads running on your processor, and the virtual thread is I would say abstraction over them. And for you, they are, as a programmer, they're technically the same. Once the virtual thread is blocked, the JVM unmounts it and gives work to other threads. Once the virtual thread is unlocked, the JVM scheduler will see, okay, we have some processors here. Let us put it there. So it uses continuations, the famous computer science continuations, as a foundation for that, but no external API is there. Just some additional methods are there. And for Helidon, we support them out of the box, although it's a research project coming it's maybe a few releases of Java from now, but we already do support it. And actually there's only one property for that. So we just enable virtual thread and it will work. In Helidon SC, you simply don't need them because you are already unblocking by the nature of Helidon SC. And let us make a small example. So we have turn point, slow and quick. So slow and points takes all of the thread, and while it's waiting, the quick actually will not be able to work just because the slow thread has blocked everything. So whenever you have this situation, what can you do? You can just create more threads, which is not a good solution, So more than 400 threads, normal machine can barely handle. You can rewrite everything in reactive way, unblocking way, using Helidon SE. Then the performance will be also known with C, but then everything has to be reactive. So you have to use Helidon SE everywhere, and the chain of the calls, from the call to the beginning, everything has to be reactive and asynchronous. Or you can switch to Bloom. And this is actually what we're going to do now. There is an example I have prepared, not me. This is an example done by our wonderful colleague, just a second, wonderful colleague, Thomas Langa. He created a server which has only two resources, quick endpoint and slow endpoint. IntelliJ sometimes break. And we have two clients, which are quick client who monitors only the quick endpoint and gathers the information. There's more code here, and slow monitors only slow endpoint here and gathers the information. As the project itself, the control of it is actually done with only two properties. So we just enforce them here. So if we use executor virtual, all the threads will go virtual in our machine. If we say no loom, it will just be false. So there will be real threads used there. And there is this very same operation done with Helidon SE I just showed you. You see, sorry, the IntelliJ is broken. I will write them something about it. But there were some tricks to make sleep operation, because when it's reactive, you cannot sleep. And it has the same endpoints. And let us actually do the stuff I have prepared for you and see how it works. So there is a window setting for all of them. So I will just have to switch to JDK 19 because we are now looking for the future. JDK 19, JDK 19, not CDK, JDK 19 and JDK 19. Yes, it's not there, but we're already working with it. So what we have, let us start the client, which is quick. Where is it? Yes, it will start, pulling the results from quick endpoint. Let us start the endpoint, not endpoint, but client, which is slow. It will point to work for slow endpoint. And now we will start our client with no loom option first. Yes, it will use regular executor. And what we have here, you see the slow endpoints, we received the 10 endpoints with no problem at all. So we have 10 threads. I limited them to 10 threads. And here it barely starts working polling because all the threads are actually occupied by slow threads. It tries to pull in, but no threads are available. You see, it's ugly. So all the small threads, all these slow threads occupied all the threads, and they just stay blocked there. Now, if we do reactive, so Java -jar JJ target reactive, this is the very same code but written with Helidon SE. It starts much quicker, but look, there are block threads, which is slow, but we still have unblocking operations serving the quick threads, and there are a lot of them. That means just with doing these things reactive, automatically unleashed a lot of our processing power. So the blocked threads are now unblocked in reactive asynchronous way, and they work, as you see here. So this is like, you see, they're serving requests. That's why I get a lot of performance if you rewrite everything with Helidon SE, which is a reactive way of doing stuff. Cool. But if you're a big enterprise and you don't have the money to rewrite everything, let us change just one property in our MP, which is blocking way. And the very same code, you see, it starts like a lot of change, only one property change, but we still gain more and more performance, although the code is blocking. Still less than here. You see 8,000, maybe they will get to 10,000 requests or even more, but still the same as reaction, like go. So that's why I just want to show you that reactive way, you unleash great power, but maybe something will change in the future. Let me just stop everything. And even when you write blocking code, the JVM will take care of what is actually you do. So Loom is a game changer, but the reactive currently with the build we have is a little bit faster. I would say twice faster, but this can have changed a lot in future because I'm still using JDK builds, which are experimental, so it's hard to measure, but we already do support them. One small announcement that we are now working on a project called Nima, which is a completely Loom-based blocking server, which uses all the latest stuff with virtual thread and has switches, sealed classes, system loader, and it's a pure JVM server, which has no underneath, like Netty still has something like machine-specific code. And with this thing, we gain more performance in a blocking way using Loom. So it's just an announcement. It will be open source very soon. So as a result, you can read more information about Helidon, but in this public channel. So Twitter, Medium, GitHub, the code is there, issues are there. YouTube, we produce videos, so you can ask us in Slack. But once again, Reactive is really awesome if you understand and if you do everything Reactive. And if you don't, just wait a little bit. Loom is coming, but wait a little bit, maybe years actually from now to production. But if you need the performance, Reactive is there, and Helidon provides you these two wonderful flavors. So you choose what you need. But for portability and standard way, or Reactive layer, which releases a lot of performance. Thank you so much for this talk, and I have some questions. Pivotal dominates on the market. What is Helidon's strategy to make some piece of this market? First of all, as you see, it is there. It's open source. Use it. That's why I'm here. Then there is so we are establishing now a strategy with Oracle how to put it more into market. But in Oracle itself, actually, we have several amazing projects. One of them is I can't say them right now, but one of the projects is consuming like tens of millions of events happening every system, every second, and it uses Helidon underneath, and it's just the best out of class performance. So in Troy, Oracle is very widely used for thousands of people, but we will now go also in the market, and we will try to push as much as possible. Oracle is the supporter for Helidon. So Oracle now it's an open source project. Everybody can join. We have contributors from other projects as well, like MicroStream, like Neo4j, etc., etc. So we are like cooperating. So it's an open source. Main is Oracle, but we have a rule that if somebody gets a PR, so whose PR comes first, I will pull request. It shouldn't be Oracle people who will do this, but we are now currently the main supporter. So how fast it is according to gRPC and Go? I personally don't have any observations on that, and I think I have to do it and publish it. So I know that we have some web services who are using Go, but they migrated to Helidon because it was performing better. So this is what I can say here. I took more time because of the shift, so sorry for that. And once again, thank you so much for listening. I really hope I answered your questions. If I'm not, just ping me on Twitter. As you see, so here are my slides. I will do my best to answer them. And as you say, Tashkura, thank you so much.
Yeah, we have all the questions, and we forwarded to you. So I'm just checking again if there are any. Generally, people thank to you, Dmitry.
Thank you so much.
And
I really hope it was useful.
Yeah, Koray again says congratulations, nice presentation, thank you. So we also thank you, Dmitry, sharing valuable information with us. And we will have Sven, but he has technical problems, so we will have a 5 minutes break, and after that we will continue. Dimitri, thank you again. Enjoy the rest of the conference. Yeah.
Yes, thank you so much, and probably next time I'll be in person.
Yeah,
we'll really hope to do this. Yes, and Sven is awesome. Just send many greetings to Sven, and he's a great speaker. So enjoy. Thank you. Bye bye.
Yeah, thank you. If there will be no any pandemic, we will hopefully meet you.
Yes, I really hope so. Yes. Enjoy your day. It was a great pleasure.
Yeah,
Bye-bye.
thank you very much.